This is a video for 5.1. We're starting exponents. We're also going to look today at function composition. We'll talk more about that in a second. First thing here, we've got a list of properties. Basically, this section is an introduction into the different properties of exponents. They shouldn't be brand new. Most of them you can kind of reason out. We'll go look through them here, and we're going to spend much of the time practicing. The first one is the product property, and this is one that we can show quite easily just by writing it out. But basically what it says is that if you've got two powers with the same base, you are simply going to add your exponents. So f to the 7th times f to the 5th is going to turn into f to the 12th. And we could show that by writing out f to the 7th. We know is f times f 7 times. F to the 5th is f 5 times. And if we look now at the total, we've got 12. A power of a power, this is when you have an exponent with another exponent raised. So this one we would read as 6 to the 2nd all to the 3rd. Over here, a to the m all to the nth. And this is a product. You multiply those two numbers together. So we are going to multiply 6 and 2, and this becomes 6 to the 6th. Much like the product property, we can actually write this one out. Remember what 6 to the 2nd to the 3rd really means is 6 to the 2nd times 6 to the 2nd times 6 to the 2nd. And therefore we could just go back to our product property, the one above, and say, well, this is going to be 2 plus 2 plus 2, and you end up with 6 to the 6th. One of the most important rules to remember is the difference between the power of a product, which you see in this example, and then the power of a sum, which is one that we see quite often in our work in quadratics. When you have two things multiplied together, you essentially can think of this as distributing this 7. So this would turn into an x squared to the 7th times a y to the negative 6th to the 7th. You cannot do that here. You cannot do it over addition or subtraction. All right, you don't distribute this, you expand it using FOIL or using the box method or whatever other manipulative you have. When they are multiplied together, like the example here, you simply distribute that and carry out the operations as you know them. So we would take 2 times 7, and we would multiply, because we have power of a power, negative 6 times 7. So 2 times 7, this becomes x to the 14th, and this becomes y to the negative 42nd. Now we'll look ahead here and we'll just deal with that negative. But these properties are pretty important and things that you will be asked to use throughout Chapter 5. Okay, moving on to some other ones. What do we do with that negative exponent? Well, a negative exponent, there's a couple ways you can think of it, but I like to think of it as simply the opposite. It's an inverse. So an exponent is really fast or a quick way to write multiplication. You know, x to the 14th is x times x times x all 14 times. Well, y to the negative 42nd, I like to think of this as division a lot of times. So it's 1 over y to the 42nd. And that may not be the exact mathematical reasoning for it, but it works for our practices here in Algebra 2. So we would rewrite this as x to the 14th times 1 over y to the 42nd. Notice that your negative becomes a positive exponent when you move that to the denominator. Right? When you finally do move that to the denominator, it turns from a negative to a positive. Anything to the 0 is 1. That won't be anything new for you. 7 to the 0 is 1. 2.5 to the 0 equals 1. The reason that we need this to be 1 and not 0 simply stems from the quotient. If you actually look ahead here, the quotient property says that m over n, as long as you have the same base, you are going to subtract them. So this is going to turn into 4 to the 5 minus 3, which is going to be 4 to the 2nd. And you can kind of think of this as division, really. We're going to divide out This is 4 times 4 times 4, 5 times. In the denominator, we've got 4s, 3 of them. They're going to cancel out, leaving you with just 4 to the second in the numerator. And it's faster just sometimes to subtract them rather than writing them all out. And you can have negative numbers. So I'll give you another example of that. If you have more on the denominator, okay, I like to think of it as who has the bigger power. So if you've got, let's call it x to the 7th over x to the 10th, you simply take x to the 7th over x to the 10th is going to be x to the 7 minus 10, which is x to the negative 3rd. Now, knowing what we know about negative numbers, this really means division, so it's 1 over x to the 3rd. And you can kind of see how we go from the first step to the last step is just simply, well, all of these are going to cancel. 7 of them are going to cancel here, and we're going to be left with x to the 3rd. Now, how does that play in with up above? Well, if we look back here, how do we get a 7 to the 0? Well, 7 to the 0 could come any number of ways, but one common way, or one easy way to think about it is, well, what if we have the same amount on top and on bottom? 7 over 4 over 7 over 4. This would be 7 to the 4 minus 4, which results in 7 over 0. Now, we don't maybe know what this is, what is it supposed to be, but I definitely know when we have the same thing on top and on bottom, this should equal 1. So therefore, by conclusion, we know that 7 to the 0 has to equal 1. So anything to the 0, any number to the 0, positive or negative, will be 1. The quotient property, the last property here, is just another version of our power of a product property where we essentially are distributing the m to everything in the parenthesis, even if it's a fraction, both the top and the bottom. So here we have a pretty complex example. We're going to take this 3 and we are going to distribute it to every single thing in this parenthesis. Remember here that negative 2 and a squared, those are really different things. Oftentimes we like to say negative 2a squared, but really it's negative 2 times a squared times b. So you have to remember to square the negative along with the a squared. So it will become negative 2 to the 3rd, a squared to the 3rd, b to the 3rd, over a to the 5th to the 3rd, and b to the 3rd. Now we can simplify now. We could have simplified before we distributed that 3, but we will have some things cancel out. A b to the 3rd cancels out with a b to the 3rd. We're going to have some a's cancel, but let's simplify them first. We will have a negative 2 to the 3rd on top, and a to the 2nd all to the 3rd is going to be a to the 6th, multiplying power over power. A to the 5th all to the 3rd is a to the 15th. And we just look at how many a's on top, how many a's on bottom. We've got 6 a's on top, 15 a's on bottom, so all of them are going to go away here. We're going to subtract 6 away from there, leaving us with 9. So 6 would cancel top and bottom. All of them are gone in the numerator, leaving us with a negative 2 to the 3rd over a to the 9th. So here are a couple of examples I'd like you to try. Go ahead and pause it right now and see if you can simplify these, canceling terms where you can, moving negatives from either the numerator to the denominator or vice versa. If they are in the denominator, move them up to the numerator. All right, hopefully you've had a chance to try these on your own. Let's look through them here. The first thing that I would do is cancel. Anything you can cancel right away. When you're multiplying a fraction, you can kind of write it all as 1 across here. And we have a y to the 3rd on the bottom, a y to the 3rd on top, and those are going to cancel out. We also have a 2 and a 2. So in the denominator, we just have a 1. Often you wouldn't have to write that. In the numerator, we have an x squared times an x to the 4th, x to the 6th. And so I would write our final answer as x to the 6th. There's a couple ways you can attack this one. I would say, let's just distribute that negative 2. Let's just take care of it. So I'm going to move this negative 2 to everything, right? There are really kind of 4 different terms here. 2 on top, 2 on bottom. Each of them is going to get that exponent. So I'm going to have a power of a power. I'll have x to the 7th all to the negative 2. That's going to become x to the negative 14th. I'll have a y to the negative 2 all to the negative 2. Those are going to multiply to make 4. This 3 to the negative 2. And then it's y to the negative 3rd all to the negative 2. So that's going to become y to the 6th. Now before I do any more simplifying, we need to take care of the negatives. We really don't want to simplify while we have negatives because they're truly not in the right spot. So canceling them would be a little bit deceiving because maybe that is supposed to be in the denominator. So we need to take our 2 negatives and we need to move them. Wherever there is a negative, you need to move it to the other side. So this one is going to go down, and that 3 is going to move up. So it'll become 3 squared y to the 4th over x to the 14th y to the 6th. Notice again that your exponents become positive when you've moved them. Now the last thing to do is to simplify, and we've got a y on top, y on bottom, so they're going to cancel out. 4 on top are going to cancel with 4 down below, leaving us with only 2. So our final answer is 3 squared over x to the 14th y to the 2nd. You can leave 3 squared just like that. I know that 3 squared is 9, but leaving it as exponents is really what we're working on here today. Alright, the last question on this page was a little bit different. It essentially asks you, what do you need this to be? What goes in this spot such that you will make this true? And there's a couple of different ways you can think about this. You could just put a variable here, and you could just call this x. You know, maybe call it big X, or even a different variable. Let's say you just want to call it m. You could call it m and then solve for m. So you're going to multiply both sides by the given information. I'm going to go a little bit differently. I'm going to say, well, what do I need to put here so that I will get 2 over 3? And then what do I need to put here so that I will get an x? And then I will get a y squared in the denominator. So I'm going to get rid of this equal question mark for now, so I can write in this spot. So the first thing that I'll tackle is the numbers. Well, okay, we need a fraction of 2/3. 2/3. We have a 9. What do I need to put up here so that it would reduce to 2/3? And the answer is I need to have a 6. We'll go to the next thing, and I have an x in the numerator. I have 1x, x to the first. I have an x squared in the denominator. I need 1x left on top, no x's left on the bottom. So I need to have, in this space here, I need to have x to the third. Because x to the third over x squared will simplify to 1x on top. Keep working our way down the alphabet here. Y, we have 2y, or y squared I should say, in the denominator. We have a y to the 6th. What do I need in the numerator so that in the end, net result, I will have a y squared in the denominator? Well, I need this 6 to cancel. I need some of them to cancel, not all of them. I need exactly 4. Finally, the last step is z. I don't have any z's over here, so they better cancel all together. So I must have one z top and bottom. And there is your answer. 6x to the third, y to the fourth, z. Function composition is the last thing, and this is how you'll be assessed on your test. Function composition essentially allows us to put anything we want in a function. Remember, or something to think about, is that x here really represents your input. So when you see a 5, that's telling you, in this situation, that we want to input 5. So it'll be 3 times 5 minus 4, which ends up being 15 minus 4 is 11. Well, you can put anything you want. If you wanted to put a t here, then it would be 3t minus 4. You can put a smiley face, f of smiley face, equals 3 smiley face minus 4. More importantly, you could put a whole nother function, or some other terms. So what if I say I want 2y, then I would have 3 times 2y minus 4. Just remember that whatever goes in here is whatever goes in your input spot. And x is usually what we keep as our input spot. So let's look at these examples. What does this mean? Well, if we're taking the function and we want to put in 7w to the fourth, then wherever there is an x, we need to put 7w to the fourth. So it's going to turn from negative 5. Instead of x, we are going to put in 7w to the fourth. Now that thing is being squared, plus, here's another input spot, x, we are going to put in 7w to the fourth. And now you're going to use your rules of exponents to simplify. The negative 5 will stay in front. We are going to distribute this 2 to both the 7, so it'll be a 49, and to the w to the fourth, so it's w to the fourth all to the second, is w to the eighth, plus 7w to the fourth. And we'll simplify negative 5 times 49, 245. negative 245 w to the 8th plus 7w to the 4th. And that's your final answer. Again here, we are asked to input w plus 1. So I'm going to plug that in, and I'll write it as negative 5 input squared plus input. What are we inputting? W plus 1. W plus 1. So wherever there was an x, you're really replacing with your input. This time we have to use some different rules, things that we've been practicing a little bit more with quadratics. You will need to FOIL this, or you will need to use a box method, or some way you need to deal with this. You cannot distribute that too. So the first thing that you do is leave the 5 up front, recognize that this is w plus 1 times w plus 1, and you can FOIL or use the box method. You end up with a w squared plus 2w plus 1, and then finally over here we still have plus w plus 1. Now I'll distribute the negative 5, and start simplifying. It's negative 5w squared minus 10w minus 5 plus w plus 1. Combining like terms, here and here, gets us to our final answer, negative 5w squared minus 9w minus 4.